I'm here ready to start working about many topics of 6th grade, 7th grade, about direct variation, about probabilities. We're going to work a lot about these topics today, and I'm just setting everything off. First, I think I need to change this information. Starting probability, direct variation, graphs. Okay. Put here. Let's work about let's see something about here. Okay, I think I'm ready to start. We're going to work today on exercises. So I'm going to focus on only exercises today. I'm just going to work out on everything regarding direct variation and the stuff. So we're going to start with questions of direct variation. I'm going to work out only one question per topic, and then you must verify how to work out different questions about the same topic. Okay, I think you can see it. Good. So we're going to start. Let's go. We're going to start with direct variation, a topic of direct variation. And I'm going to work out this question number 1. So it says, Carly bought a new printer for her computer. It takes 7 minutes to print a document with 63 pages. How many pages can it print in half an hour? How much time does it take to print a 324-page document? And we're going to solve it first by doing a table, because we're going to work out on direct variation or on unitary rates or using rates to solve. So there are many ways to do it. One way is direct variation, the other way is using unitary rates. You must choose the best for you. But first, in any case, we're going to do a table about this. So you need to identify the two magnitudes that in this case are pages and time. Look at, because it says it takes 7 minutes to print a document with 63 pages. So the time, minutes, is going to be 7, and the number of pages, 63, is going to be here. So we have 63 pages, corresponds to 7 minutes. Now the first question, A, says how many pages can it print in half an hour? Half an hour is just 30 minutes, right? So in 30 minutes, I don't know, I'm going to put A, I don't know what's going to be the number of pages. And the second question says how much time does it take to print 324 page document? So it means that I know the number of pages, 324, and I want to know the time. I'm going to call it B. You can call it P and T, there's no problem, but the idea is that you collect the information in a way that you can solve it. Now, using this information, we're going to formulate an equation to be answered. So the equation for A corresponds to direct variation. So remember that if you're going to apply direct variation is just that I can pass from pages to time or from time to pages by using always the same multiplier. So in a way that if I divide 63 and 7, is going to be the same as A divided 30 and 324 divided B. Okay, so this is direct variation. So the way to apply direct variation is that you go to the opposite, multiply the cross numbers, and the answer divided by this number here. Okay, so this is the way you can get your formula. 30 times 63 divided by 7. Now you can also find out the unitary factor. How to get the unitary factor? Every division is going to be the same. So it means that 63 divided 7 must be equal to A divided 30. This is another equation you can use. And look at that, I just need to multiply by 30 to get the answer here. Okay, so it's going to be exactly the same. And in B, if you think of this way, it's like, okay, but now B is in this place of time. So it means that 7 divided 63 is going to be the same as B over 324, right? Because the ratio are equal. There are equivalent ratios. So if you use equivalent ratios, you can also formulate the solution of direct variation problems. But in this case, so if I multiply by 324, is going to be here. Or if you apply directly, the idea of direct variation is going to be, I'm going to use green here, 324 times 7 divided by 63. So 324 times 7 divided by 63. Now, to solve this type of equations or expressions, you can use dividing by common factors. So you can divide by common factors, and instead of multiplying 30 by 63 and the answer, this large number divided by 7, you can just take and simplify by common factors. So let's see how to do it with common factors. How to do it by simplifying by common factors. So we're going to put A, that is equals to 30 times 63 divided 7, and I'm going to simplify by common factors. Now observe that there's no common factor between 30 and 7, but there is a common factor between 63 and 7, because both are divisible by 7. So if I divide by 7, this is going to be 1, and 63 divided by 7 is going to be 9. So in this case, I'm just gonna get as an answer 30 times 9 divided 1. So it means that A is gonna give you 270. I didn't put units. It's important for you to put units. Don't remember. So 63, it's this is minutes, this is minutes, this is pages. So it means that minutes with minutes are canceled. So the answer is going to be pages. Now what happened with B? We're going to do B. B equals 324 times 7, times 7, not times 6. Not 6, is 7. 324 times 7 divided 63. So look at that, I can perform exactly the same division by common factors. I can divide by 7 both. 7 divided by 7 is 1. 63 divided by 7 is 9. And now I can simplify 324 by 9. So I'm going to divide 324 by 9. B is 324 by 9. Now remember that you can divide these numbers in any way. There's no problem in the way you do it. But I'm just going to show you my strategy to divide by 9. Maybe if you're not quite sure, you can divide by 3 first. And the answer divided by 3 again, like simplifying the fraction, but I'm going to do it immediately. I'm going to divide by 9, so this is going to be 1. And now I'm going to divide by 9 this whole number. 3 is not divisible by 9. So I'm not going to divide 3 by 9. It's going to be 0. I'm going to move to the next. 32 divided by 9. It's going to be 32 divided by 9. It's going to be 3, right? Because 3 times 9 is 27. And 27 to 32 is going to be 5. So I'm going to put here a small 5. So it's going to be the new number, 54. 54 divided by 9 is 6. So the answer is going to be 36. 36, but remember the units. Remember the units. This 324 refers to pages. This 63 refers to pages. And this 7 refers to minutes. So it means that the answer is in minutes. So B is going to be 36 minutes. So look at that in this way. we just calculate or we just solve a problem of direct variation. I recommend that when you're learning direct variation, first start by doing the table, because the table is going to help you to identify the magnitudes and the variables. And after you identify the magnitudes and the variables, you can find out by direct variation. Remember that you can find the unit rate. So it means I can just find out what is the time it takes to print one page, or I can also get what is the time, what is the number of pages that I can print in 1 minute. So in this way, you can calculate also this type of problems. That is kind of the same thing that we did. Okay. Now we're going to another question. Let's see another question about probability. Let's choose one that we can, in which we can see a lot of things. Could be this one. I'm going to just work out on question 4 that says probability. A bag has 10 balls labeled from 1 to 10. A ball is chosen at random. List of the possible outcomes. So I'm going to put all the possible outcomes. I'm going to list all the possible outcomes, and all the possible outcomes, remember that you put it in brackets, will be the numbers from 1 to 10, because represents the number of the ball that I'm going to pick. Okay, so you just need to list the numbers from 1 to 10 in order to represent the possible outcomes. Now it says calculate the probability of selecting a multiple of 3. So we need to find out here multiples of 3. So multiple of 3, multiple of 3, multiple of 3. So if you observe from these 10 balls, 3 are going to be multiples of 3. So the probability of getting a multiple of 3 is going to be 3 out of 10. So if you need it as a decimal, remember that it's divided by 10, so you move the decimal point once. You can put 0.3. Or if you want it as a percent, you just need to multiply this decimal by 100 to get 30%. Any of these 3 answers will be allowed. Calculate the probability of selecting a factor of 20. A factor of 20. So I'm going to use another highlighter, green, to highlight the factors of 20. 1 is a factor of 20, 2 is a factor of 20, 4 is a factor of 20, 5 is a factor of 20, and 10 is a factor of 20. These are the factors of 20. So essentially, the probability that I got a factor of 20 is going to be 1, 2, 3, 4, 5 outcomes out of 10. Remember that in fractions, you don't put the answer as any fraction. You must put the answer as a fraction in lowest terms. In this case, will be 5 divided by 5, 1, 10 divided by 5, 2. So it's going to be 1/2. So the probability if I got a factor of 20 is going to be 1/2. Now 1/2, if I convert it to decimal, is 0.5, or as a percent is 50%. State a mutual exclusive event with selecting a number less than 4. So the objective here is that you understand what are mutual exclusive events. So an event is mutually exclusive with other that when one event happens, the other cannot happen. Okay? So when one event happens, the other cannot happen. It's impossible that happens. They cannot pass at the same time. For example, calculate selecting a multiple of 3 will be mutually exclusive with selecting a number less than 4. No, because in the multiples of 3, if I do the list of the multiples of 3 that are here, 3, 6, and 9, and I do the list of the numbers less than 4, 1, 2, and 3, I have an intersection between these two. So 3 is possible to happen at the same time. So this cannot be a mutually exclusive event. Same thing with the factors of 20, because in the factors of 20, it's 1 and it's 2, that this is less than 4. So you must select any other mutually exclusive, any other event that it's going to happen, but not at the same time with a number less than 4. So for example, I'm going to put an event. For example, I'm going to put select number 5, for example. If I select number 5, I'm going to select a number that is less than 4. For example, select a number greater than 6. If I select a number greater than 6, it's not possible that I select a number less than 4. You see, there's no option. There's no option. There's no thing, because you can tell me, Mr. Hugo, about multiple of 3 and 4 could be mutually exclusive because 2 is less than 4 and is not a multiple of 3. Yes, that's correct, but 3 is less than 4, so it can be selected as less than 4 and multiple of 3. So be careful about that, because it's usual that this happens when you're working on finding mutually exclusive events. I just want to test that my chat works. Yes, it works. Okay, so be careful about selecting numbers less than or greater than a number. This is some idea of mutually exclusive events and how to calculate probabilities. And we're going to finish this review with, let's go to another question. Could be this question. Yeah. We're going to see something about patterns to finish today's work. We're going to work about patterns a little bit. And it says, for the sequences below, state the turn-to-turn rule and the next 3 terms. The turn-to-turn rule and the next 3 terms. Now, identify, if you're going to calculate the turn-to-turn rule, identify what you're doing to pass from one number to the other. This is the turn-to-turn rule. What you need to do to pass from this to this. For example, 1 to 6, then 6 to 11, 11 to 16. Look at that, I'm adding 5 each time. So add by 5 each time. Look at that, I'm not going to put plus 5. I don't put plus 5. Add by 5 each time. This is the proper way to write it. And now I'm going to find the next 3 terms. So I'm going to just add by 5 each time. So 16 plus 5 is going to be 21. 21 plus 5 is going to be 26. And 26 plus 5 is going to be 31. These are the next 3 terms. This is an idea of how you can do it. Identify what you're doing every time you add. Now let's see this one. For the sequences below, state the end rule and the 25th term. So I need to know what is the end rule. So look at that here. It's like if I do a table here, like n and the term, I'm going to put that the term number 1 is 4, the term number 2 is 8, the term number 3 is 12, the term number 4 is 16. And there must be a way in which I can pass from this 1 to this 4, from this 2 to this 8, from this 3 to this 12, from this 4 to this 16. Is a way in which I can just operate in a way that I got n to get the answer. Now, if you observe carefully, in this case, you can see that you're just multiplying by 4. 1 times 4, 2 times 4, 3 times 4, 4 times 4. So what you're doing is n times 4. N times 4 is 4n. So the n rule is 4n. This is how I recommend you to identify the n term. And now if I want the 25th, so I just need to take 25th, and I know the rule already, just times 4. 25 times 4 is going to be 100, so the 25th term is 100. This is how you can identify the term. Now, in basic patterns, the n term, it will be or multiplying by a factor, or n plus or minus a factor. So this is the idea of working with the n term rule. The n term rule. And finally, let's see one that goes a little bit higher, that says, for the sequences below, state the n rule, find the n term and the 65th term. So I'm going to identify what I'm doing. Look at that here, I'm adding 1. You see? -3 minus 2. So I add 1, add 1, add 1. So this is add by 1 each time. And for the n term, I'm going to do the same. My table, n, the term, 2, 3, 4. So -3, -2, -1, 0. And I need to identify what is the operation I'm doing to pass from here to here, from here to here, from here to here, and from here to here. Now observe that if you're adding by 1, means that the n is not multiplying by any number, because it's like every time you multiply, the factor will be n times the factor. But in this case, as I'm adding by 1, I have it the same distance at n. So I need to just add or subtract a number. In this case, 1 to get to -3 is going to be -4, right? If I'm in 1 and I want to go to -3, so I need to move -4. So what I'm doing is subtracting 4. So the n term is going to be n, so n minus 4. N minus 4. This is how I understand how I can get my n term. And finally, I want to find the 65th term. And to find the 65th term, I just need to put n is 65. So as I'm subtracting by 4, 65 minus 4 is 61. That's it. And this is how you can manage to work out with patterns. This is how you manage to work out with probabilities. And this is how you can work out with direct variation. So these are just examples. We'll see you in the next video working on more questions about these topics to see more and more. And I hope that this video helps you, and I hope that you can understand what is the process involved in solving this type of problems. Let me see. I have a question. Okay. So this is it. See you in the next video. Bye bye. I hope that you like it. I hope that you enjoy it and you continue working on more math using your knowledge. Bye bye, everybody. Enjoy your day. See you.